Good morning, everybody. My name is Jason Fox. I'm the Senior Technical Evangelist at the FIWARE Foundation, and today is going to be an advanced Wednesday webinar on actuation, federation, and interoperability of context brokers. Also introducing various advanced and novel features which have been defined in the NGSI-LD 161 specification. So if you're looking for a basic introduction, this is definitely not it. But we're going to be using some of the stuff which is available to context brokers, but when you need it, you'll be pleased to know about it. So the overview for today is we're going to discuss various advanced deployments of arrays of context brokers, and a few of the features which are already well defined in previous versions of the specification, such as multi-attributes with datasetId, which is used for alternative sources and one-to-one relationships, scopes, and distributed deployments. Thinking about data spaces, trying to work out how we can move this going forward, as well as things such as federations and tenants and other stuff which may or may not be supported by various different brokers today, but should be in the up and coming roadmap. We've got an awful lot to cover today, so I'm going to move straight in with the first section, which is how to deal with multi-attributes. Multi-attributes have been around probably since 1.3.1, I believe. So, but they are not overly supported in all browsers to full specification. But you don't really need them that often unless you are dealing with multi-attributes. You see, there is fundamentally an issue here, is that if you think philosophically, when you have an attribute like speed, you're talking about speed. You know, whether it comes from a speedometer or a navigation system or an external sensor, the context of the entity is saying, I'm going this fast. And it doesn't necessarily mean that you want to keep changing the speed attribute every time there is a something coming to the speedometer, but not from the navigation system or not from the external sensor. But they are systematically different. It might be the case that you want to get the speed from your less frequently updated but more accurate version. It might be the speed that you want the most recent version of whatever sensor, and then you can have additional metadata saying, you know, my accuracy is this, that, or the other. But fundamentally, there needs to be a mechanism to work out when you have a single attribute which could have multiple values. How do you obtain the multiple values from that system? And the way that NGSI-LD deals with it, this is not a feature which is available in NGSI v2, is this addition of datasetId. Now, datasetId is another non-rarefied attribute which goes into the along with the type and the value, or the type and the object, and it's a URN. It's a distinguishing marker for saying, in this case, the speed is coming from the speedometer, the speed is coming from the GPS system, the speed is detected by a camera. Now, what will happen is that these are different values, and they are, although they are within the same attribute, they can be updated independently, they can be deleted independently, they can be changed independently. When you request an entity, you can request a certain dataset ID, or you can get back the lot and find out how you want to filter, because obviously whichever application is reading this information is it's up to them to work out what is most important for them. Now, for the 95% use case, you don't use datasetId. datasetId is the default without no datasetId, or perhaps datasetId without none is the default value for datasetId, which is going to be the vast majority of your attributes. Of course, you can get hold of the information as you see fit. these are all considered as distinct values. The way you would create it is, as you would expect, you can add in multi-attributes as part of your normalized, or indeed part of your concise data format. You can see on the left there we have just done a post to create on the entities endpoint, and it's like type value unit code was saying this is where we are coming from. You can also add in additional attributes using the same mechanism. So it's like having an ability to avoid having speed from camera, speed from this, speed from that as separate attribute types, which is obviously useful when you want to start retrieving information. You can see here that the ID for the actual entity, for the actual vehicle, is the same for both of those, both the create and the update. It's the same URN. Obviously, if you wish to update a single value, you can do that as well, provided you place the dataset ID. But when you do the query, what will happen is that you, instead of getting a single attribute back, you'll get an array. So you can see that speed here has got an array of values, and in this case they've all got the same unit code, which is rather useful, which means that you could work out what the information is for each one. Each one of these speed values could indeed have properties of properties, which would be specific to that particular reading. Now, beyond properties, you will find that multi-attributes are required for relationships. If you look at the definition of object in the core context, it says the object is an ATID. It's a pointer to a single entity. I've just put the names here for clarity, but they would normally be URNs. And of course, if I only have one friend, I can point it towards John. But if I have multiple friends, I want to have a different dataset ID for each one, so that ontologically a friend is still a relationship. It's still a pointer to another entity. But of course, I would have multiple relationships. I've got more than one friend. So in this case, you can see David has become my new best friend, and I'm just updating the property of the property with as the value that he's my best friend is true. Now this is obviously required for this directional system. This is dataset ID is on relationships is supported in Orion-LD. Dataset as a whole is supported by scopeQ. I believe it's coming in Stelio fairly soon, so it's not entirely there. You can also use dataset ID potentially going back to our dataset ID on the properties. You could use it for sequential commands potentially, because you could have do this followed by do that followed by do that as being one property on a command, which you could go forward. Again, that's not really well supported by IoT Agents yet, but it's a use for dataset ID, which should be coming soon. The next thing to look at, and this is usable, this is the equivalent of the old FIWARE path header, is that you can have a logical separation of entities using the scopeQ, scope and scopeQ parameters. Now, scopes are useful when you have a hierarchy of data, or indeed a hierarchy of brokers if you are federating. You could imagine a situation where you'll have one broker which has got all this data, but equally, I might have a broker just for Parque Norte, for example, which if I wanted to get just their data, I could get hold of that information. Hierarchical structures are very useful because effectively you can do a a separated path to just get the data from a certain part of the system. There are significant differences between NGSI-LD scopes and the NGSI V2 service path, but this is now something which can be found on the entity, embedded deeply within the entity itself, and it's on an entity level, not on an attribute level, is what we are dealing with here today. Now, you can see on the entity, as well as having an ID and a type, you can have a scope, and a scope is an array, or can be an array, put it that way. So you could have a scope which has got multiple values in it. You can see this one is within a certain district of Madrid, but it's also a certain unit of a company. It's not dependent on the entity ID, and can also be used for subscriptions. You can see you can add in wildcards when you are doing scopeQ. So scopeQ can look for pretty much like MQTT topics. You can add and company A and one level, or company A and everything else below it when you're using your scopeQ. scopeQ can also be used to send multiple scopes, pretty much like the ordinary Q parameter. The comma separator is used as in this case it's an either or rather than and. But you can see that there's quite a logical way of describing how to scope stuff. Now you can also use scope when you are updating values. So you can put this into your URL when you are saying update XYZ. So you could imagine a situation where, let's say I've got all of the district data for this district in Madrid in one context broker. If I just wanted to focus and update purely on the data which has got this scope on there, I could do so. So if it was, say, just that context broker which had got incorrect data, I can say scopeQ with the update, and say it would just update entities which align with that. Now, this is useful if you have a situation where, for example, you have multiple districts, each with their own context broker, each with their own their proprietary system behind them, and you want to make a general request and make it usually to say, give me all the data I understand of the system, but you want to make focused updates. Of course, you could just say, and I want to get the data from that particular broker in a federation. We'll come and deal with the federations later. Once again, scope is usable within registrations. So I could actually say, okay, when I want to get entities of type X, what I really want to do is to get entities of type X with the following logical scope. You can see here when you are creating entities, you can just add scope like you add in ID or type. It is an optional parameter. If you don't need it, it will be the default scope, obviously, pretty much like the way the datasetId works. But you can see that you can add in multiple different scopes and multiple different locations for the same or different different vehicles. When you are doing a request, you need to add in the a parameter. Note that if I want to have /# at the end of the scope, it will be or should be URL encoded. So this is not going to be an issue when you're talking machine to machine. It almost certainly will be, but that's the reason why it's got this #23 at the end, and it will return the relevant entities. You can see that I've got here two entities from different departments in the same in the same company, but because I've got company A, logically that data has been retrieved. Next thing to look at is the NGSILD-Tenant header. The NGSILD-Tenant header is the updated version of the FIWARE service header. Now, implicitly, context brokers are multi-tenants. You can use the same context broker instance to put data for multiple different users, and they will be isolated from each other. This is quite useful because it may have legal implications. If you've got more than one client, you don't really want to be putting all of their data into a single database. You want to keep it separate from the next client. Now, by default, you would use the you just use the ordinary version of any database. Indeed, you can do it for temporal queries as well as for the ordinary queries. But you can also add in this NGSI-LD-Tenant on top of this to get data from a certain location. When you do a post with a NGSI-LD-Tenant and that tenant is unknown to that context broker, it will the relevant backing database should be created by the context broker itself. So, for example, taking Orion LD as an example, the default name of the database is Orion, and then if you have tenant FIWARE, it will create a new database called Orion_FIWARE. What the how this is done in the back end isn't necessarily relevant to you as a user. It possibly could be relevant to you if you are dealing with operations, if you want to do backing up of databases or backing up of the current system. And it, as pointed out, it achieves isolation of your data, so you can do different elements at different times. When you do a registration, typically the registration will be targeted at the default tenant. However, it is possible when you look at the fields of the registration to say, oh, I want to also put in an NGSI-LD-Tenant header to really only retrieve data from this particular broker. And that can also potentially be a wildcard placeholder. So I can say, okay, if I do a request to this particular tenant onto my context broker, the registration to the next thing in the chain would also have the same values. So this is how it works. If normally I would just do a direct request, and it's just, hey, here's a vehicle, here's a speed, here's a whatever. The difference is that I now add this additional, in this case, NGSI-LD-Tenant FIWARE to a header whenever I'm doing the post request, or indeed when I do the get request. If I do a get request, I'm getting the vehicle 32 here, but if I'm doing it for the tenant, I would get the alternate set of data. This is actually quite a good way to find out that you've got no data in your database, because if you forget to put your tenant header, it won't find all the data, it will find none of the data. So if you're scrabbling around and think, oops, I've lost all my data, this is probably the reason why, is that you forgot to put the wrong tenant header in, or you put in a tenant header with a spelling mistake. The NGSI-LD-161 specification, which came out in September, has got a lot of new features and clarifications around registrations. This is going to make life a lot easier to create proper data spaces, and it also clarifies what the way that we think context brokers need to align so that they are truly interoperable in federation. The simple deployments, and this is typical for NGSI v2. You usually have, one operator. I've got one context broker. I might have in an NGSI v2 case, I might have multiple context brokers which are pushing to the same database, which is effectively a kind of federation light. But basically, I have one system, right? Not a problem. The problem occurs when you need to start adding in multiple brokers talking to potentially multiple thousands or even millions of entities across different systems. This is where you could have some bits of data in one context broker, some bits of data in another. You might want to be able to get certain parts of the data from some systems. You might not allow them to get certain things. It starts getting very complex when you start dealing with data spaces. So there needs to be a rule book, a set of requirements for LD brokers to say, yes, we are all going to work together to do federation in the same manner. Indeed, if you look at the so the old 151 specification, you'll find that scopeQ covers federation as you would expect, whereas Stelio and Orion LD have concentrated on the actuation use case rather than the federation use case, which means they're more likely to be based on the simple deployments and actually doing stuff on the far end. But specifically for federation, the following will happen, is that you have multiple context brokers. They can the data is spread in multiple locations, and you can get hold of the aggregation of the system. So when you're talking about context brokers, you're talking about smart solutions. I can make a better decision if I've got more information. So obviously you want to gain whichever information you can to make an overall holistic decision based on what the whole system knows. So the more information we've got, the better. So it is possible to register hierarchies of brokers. You can say, okay, this broker is registered that broker is registered that broker is registered that broker. Or you could say, okay, that context broker has got everything in the Madrid area, so it's got a geographical region, so it will just deal with a certain system. But this, as you can probably guess, gets very, very tricky. Federated deployments mean that as far as your information is concerned, it's mainly to do with getting. It's mainly to do with getting because we don't necessarily know if the registrant is going to be online. We don't necessarily know which registrants we'll be able to get data from. But what we want is to get as much information about entity X as we can. It's not technically different. I mean, it's all the same, but as you'd expect with ordinary registration, context registration. But the important point is there's no central control. So I can't state that that broker will be up. I can't even state that that broker will always use the same attribute names as I've got. That's the whole point about having this app context in there. It's more a case of we're doing our best effort to get hold of as much information as possible. Now, in theory, you could actually extend this so that I could do actions onto the system. I could do patches. However, again, the majority use case of proper federation is get. You update locally, but you get across the entire federation. So if I update my vehicle in my driving license context broker, and then I do a get from the local authority to get it across all systems, then that change will be available to me. I can't update it because I haven't got the authority to do so, but I will get the updated system. So local updates, but gets and indeed potentially subscriptions are cascaded. So this is the basic way which you would normally have the architectural role. You would have your context consumer talking to a broker, which would then get hold of the information, and of course the context producer would be updating the broker. However, with a federated system, you could have multiple sources. So the broker is transparently forwarding the query request down to another context source. It's got a context registry which can say, okay, I can get data from this location as well as that location, and we can get hold of information from multiple places. Now, it gets more tricky than this in that you can actually have multiple data spread in multiple locations. So in this particular case, we have got in our federation broker, the one which we are making the query, we've got a vehicle, but we've also got other additional vehicles in our registrants, our broker 1 and broker 2. You can see the total of 3 vehicles known in the system, one of which is known locally, but 3 of them can be obtained overall. In this particular case, you can make a single request, say give me vehicles, and you can see here that what we've got here is that we've already put in a registration for saying I've got I can also get vehicles from broker 1, I can also get vehicles from broker 2, and it's saying, okay, well, when I do my get request, oops, there we go. When I do my get request, I will retrieve all 3 vehicles, because it will get from my local broker, it will get from broker 1, and it will get from broker 2. And you can see I've got 3 separate entities. My entities are separated into different locations. The alternative is that you have a single entity where different aspects of that entity, or different, in this case, we've got the speed is in one broker, we've got the bearing in another broker, we've got the name of the vehicle in a third broker. It is held in different places. Once again, you can see we would have the same registrations on the system. When we get the information, we would get the whole holistic viewpoint of that particular broker. So you can see we're very much concentrating on gets, but there is actually the same concept could be added to subscriptions. When I do a subscription, I could make a subscription, tell me when the speed has been updated. If I have a federation set up, the federation broker would actually forward that create subscription down into, this case, broker 1, which would say, okay, I've got information, the speed is currently 9.9 or whatever. So it would actually trigger the request. You can add in additional additional values for the multi-attribute case. Again, perfectly well supported using datasetId. Not a problem. You can do it in the kilometers per hour. You could do in whatever units are necessary, depending on what value you've got. And once again, you can get the information coming through. Now, you can also get a request for the same entity where you would get the data from the federation broker, and you would get the same data with a datasetId from a broker 1. So this is a way of distributing your data to multiple context brokers. Now, as you would expect, tenancy is also transparently covered within the registrations. So you could set up a registration which says, okay, I want to get my vehicles from that context broker over there using this NGSI-LD-Tenant header. So it's optional. I said next slide, I put that earlier, and you can get this interaction as necessary. So you can change the name, and you can change the name of the tenant. You can change where you're actually retrieving the data from. Tenant information is a string which can be found in the CSource registrations object, and you can see it identifies which specific source I'm getting information from. But there is more. There are multiple other ways of distributing your data which also need to be supported. Support for actuations is the basis of the NGSI v2 registration. and it'll also cover lazy attributes, because they were very much dealing with getting data from devices to an IoT agent to a context broker backwards and forwards. But you can also use a separation of your system. You could actually have a system where you have one God broker over the top, which is then distributing data to different brokers further down a hierarchy. It is obscure to the actual end user where the data is coming from. They just get what they need to get, and obviously you can obtain the information you need. You can also have a situation where you are using backup sources. You know, if I haven't got something locally, go off and get it from somewhere else. It is possible in these advanced scenarios that maybe you don't want everybody to access everything. You might want to have, like an IoT agent, only a limited number of operations which are available. You know, IoT agents don't do subscriptions. Subscriptions are a part of the default for federations. Or you might want to say that I can do this if I've got certain rights. Now, obviously, regardless of what you place into your context broker, you will need security mechanisms. You need some sort of proxy, pet proxy, to make sure that no one does anything untoward. But if you're trying to make your registrations efficient, what you would do is you would say, don't even bother asking for that endpoint, because that endpoint is really always going to give you an error message. So there are, this is the additional features here are a way of minimizing useless traffic. Effectively, there are now 4 different types of operation. There are 2 so-called additive registrations. Additive registrations are where your broker, your context broker, has data about the system itself, but it also may have data, there may be data held in context brokers or registrants, should we call them, further down. The basic viewpoint, default mode of operation, is now defined as an inclusive registration. Which means, as I stated earlier, you have a context broker which registers other sources. It has data, other sources of data. We add all of this up together, and you get an overall viewpoint of the system. But that's not the only way you could add data. What you could do is you could have a situation where I have information about an entity, but I may or may not have a complete viewpoint. So let's say I have temperature data about various agricultural fields. If I haven't got a specific sensor in one of my fields, I'd like to get it from, say, the weather forecast instead. But in general, my stuff is better than your stuff. So I want to, in case of an auxiliary, is that if I have data in my own context broker, that should be used in preference to the data which is received from the auxiliary source. This means that you will always get something, but you will get your preferred data rather than necessarily getting the one which is most recent or you know, cheaper or whatever. Now, this the additive registrations are in contrast to the proxied registrations, where, as you can see in red, the context broker, the federation context broker, does not and cannot hold context data about entities and attributes itself locally. If you have, say, the battery level of a device, which is being offered by an IoT agent via a chain of entities, you're not going to have that data directly inside the context broker. It's not going to be polled for and pushed up to the context broker on a regular basis, because that will actually help drain the battery. So the idea behind the exclusive registration is that context broker doesn't have the data, but it knows where it can get it. So the difference with the previous one is that it may well have data for itself, but now it does not and cannot have data. It will raise conflict, 409 conflict, if any of this information you attempt to create in the context broker, or it will just pass it direct down. Now, the two types here are pretty similar to the two types we had for the additive one. You've got exclusive and redirect. Exclusive means that I've got the data and I'm the only one who can have the data, whereas redirect is a case of the federation broker has nothing, but there are potentially multiple sources further down. Where you have this, say, hierarchy of brokers, you can say, okay, we know that the vehicle people have got information, but so have the that town hall. But I'm holding none of this myself. So once again, you can't actually create new vehicles, because that's the job of the vehicles are all adding records into the town hall, but you can read from them, and you can get information from multiple sources, aggregating the same way as you would do from the inclusive. So you can see there are 4 different ways you can deal with this information. Furthermore, it's possible to just request data from a single context broker, not a hierarchy. Imagine a situation where you've got brokers behind brokers behind brokers behind brokers behind brokers. You could end up with a request which takes a very long time. It could time out. I just want to get what you know. I don't want to get the full data. Again, looking at that example with the battery level, right? Maybe there is a device which is pushing up sensor information. If I put local into the as the parameter, it will get everything, but not the battery level, because that's retrieved from elsewhere. You can also do this within your registrations to say, okay, I want the vehicle authority to give me their data, but please don't request further down the chain behind you. I just want what you've got. This obviously is reducing traffic. The reason, the way this works is that in 161 is that there are new attributes. The most important one being mode, which is going through the different various types of it. But the second thing here, which is depends on various types of NGSI endpoints which are serviced, is operations. We'll look at that in more detail in the next slide. There are additional fields like management which hold optional limiting factors. Again, it's all trying to reduce unnecessary bandwidth and traffic. So maybe, and again, a lot of this starts becoming optional for brokers to implement. It becomes best try. But imagine you have a broker which gets data from another system, and we know it's only updated once a day. There's no point in retrieving that data all the time. You could cache it. So there is a optional fields to try and say, well, the refresh rate for this particular source is once a day. So maybe if you want to cache this particular request, best effort, you want to get hold of the information. And again, with management info, there's even more ways of trying to reduce unnecessary traffic. Looking at operations, there are an awful lot of named operations, but you don't really need to know too much about this. What happens is that for each subsection of the NGSI-LD specification, there is a relatively obviously named operation name. So create entity is called create entity in camel case. Update entity is called update entity in camel case, and so on and so forth. So you could say, I can just do that one operation. But to be perfectly honest, you probably don't need to bother. There are currently 4 standard predefined operation groups, which would be sufficient. Now, as I've pointed out, the 161 is very, very clear that federation is the default operation for registrations. So you would be able to get all of the operations defined for federation by default. If you don't bother putting in a mode, that's the mode you're going to get. But there are two other useful groups, one for actuations and one for lazy attributes, either going to be a get or a patch for the entity attributes. Finally, the CRUD proxies, where you can actually update, delete, what have you. This is typically would be used for that redirect system where I do have the rights to change stuff. So this is basically all the standard CRUD operations in NGSI-LD, saying yes, I can update, I can create, I can modify, and so on and so forth. Obviously, if you have a situation where you need to have a mix of these, you can just add in these as a comma separated list. Local only, I mentioned that briefly. There are various other things which optionally registration management info can do. It says, okay, we can do things like caching things or avoiding sending information if necessary. This would be, again, better to say, look, if you're not getting back, if you didn't get back to me last time, I'm not going to even bother trying to request information from you again until timeout until the cooldown has occurred, or potentially you've got a slow connection. I'm going to wait until for X milliseconds to try and see if you're online, you're going to get data. Obviously, you don't want to set timeout too high because it means that your context broker won't be able to respond before that timeout has occurred. Before we go on to the conclusions, I can just show a very quick example of how we could actually use the federation over a context broker. So you can see here up on screen at the moment, I have what appears to be an NGSI request. You can see that it's actually getting hold of my store one. It looks like a nice NGSI-LD. It's got type and value, and I would be able to put in metadata as well. But actually, what I really have here, oh, wrong service, right? Well, sorry, that's why. Let me get this right. What I actually have here is an NGSI v2 context broker. Now, what we're doing here is I've created a facade on a different port, which is doing the necessary request to change the format. You can see here we've got type is postal address, and it's got metadata and what have you, which is typical of NGSI v2 compared to the previous one, ZZ, which, as you can see, has got the value, address, type, etc. Based on my headers, you can see I've got a particular link header and what have you, which obviously my NGSI v2 context broker hasn't got. Now, all I've done here is I have got a very simple proxy, which is listening on entities, entity ID, entity attrs, and what have you. And I'm very, very rough this, but I have got here, where are we? I get my where are we? Up here a bit. There we go. Okay, I get my incoming NGSI-LD request. I do various manipulations of the system. Say, okay, I want to get hold of this in concise format, or I want to want to know whether it's key values or whatever. So I can then manipulate what my forwarded query to LD is going to be. And you can see I sometimes add in the context, or I don't add in the context, depending on the, whether I'm requesting that in the header. I then do my forwarding to, in this case, it's going to be the NGSI v2, retrieve it, manipulate it back into being LD format, which is what this bit here is doing, dealing with, convert to NGSI-LD, and then we can get the data coming through as a LD broker. So you can imagine this situation where I have got behind the lines, I've got a NGSI V2 broker, and if I have an NGSI-LD broker, federative broker, I can point that to this LD broker via my proxy, and it will be able to get all the information and all the updates from the V2 broker in an LD format. This is an example of how you would use this redirect, not the redirect, the federation one. If you wanted to get a situation where effectively you want to push LD data, LD style updates to a V2 broker, that would be the redirect style rather than the or the CRUD style rather than the GET style. So you can see through adding in these additional parts of the where are we? Here we go. Registrations, we are going to get more and more ways you can make interoperability between different classes of context brokers. So, in summary, conclusions. All the LD brokers are working towards a common NGSI-LD specification. So, as they converge, you'll find that there are you can just swap in Stelio for Orion LD. You can swap out Scorpio and put in Stelio, or whatever the requirements are for your system. Now, you'll find that what I've been dealing with today are very much the advanced features. The majority of the first half of the system is features which is currently most well supported by Scorpio, but the other context brokers are coming up hard on the heels, and you'll only need them for certain advanced use cases. So don't add in this stuff unnecessarily. Don't bother by putting in a datasetId if you don't need it. Don't bother using scopes if you don't need it. But when you do need it, you'll find they're very useful. You use multi-attributes with one-to-N relationships and other sources. The main use here is really going to be relationships. You can't do relationships properly, but alternative sources are another possibility. And you can also do the logical separation or separation by tenant based on who you are. There are multiple new parts to registrations on the specification, and the latest specification to be seen here. But you must remember, specification runs before implementation. You won't find the 161 features are available today, and certainly not available across all brokers today. They will be rolled out based on operationally commercial priorities amongst the various context brokers. If you want to find out who's doing what and when, the best way to do it is to go over to GitHub and look at the roadmap for the relevant context broker. And this is really all the new stuff. You've got all these new operations. If you don't put anything in, it's a federation, i.e. query and subscribe, and it's an inclusive federation. I can hold stuff, you can hold stuff, and I can get from you. But there are all these additional modes which will start becoming available to get hold of weak secondary sources or distribution of your context brokers, which will be turning up in the coming months. There are also additional ways you can push the limit or increase the number of operations you have got. Obviously, the main source of truth here is that specification, and it will become easier to see this working across multiple brokers in the next few months. So I thank you once again for having attended today, and I hope you've learned something, and I will speak to you soon. Thank you very much.